the even numbers and odd numbers. The even numbers are 0, 2, 4, 6, 8, and so on. And the odd numbers one, 3, 5, 7, 9, and so on. You can also define the even and odd numbers as the even numbers are those divisible by 2. And the odd numbers that are not divisible by 2. Okay, so we have that all even numbers can be expressed in the following way: 2 times m, where m is an integer. And all odd numbers can be expressed as 2, let's take another number, n plus 1, where n is an integer also. And this can be proved, that every even number can be expressed like this, every odd number can be expressed like this. So let's now look at the proof. That all even numbers can be expressed like this follows directly from the definition, because an even number per definition is divisible by 2. And if it's divisible by 2, it means that there exists some integer, so we can write it like 2 times m. So that follows directly from the definition. So let instead the number be odd. So let's say a is an odd number. Then we have that all numbers can be written as uniquely as with the quotient and 2, since if you divide by 2, so it's quotient times 2 plus a remainder. And here the remainder is a number between 0 and 2, so it's either 0 or 1. It cannot be 0, because if it's 0, then it would be divisible by 2. And we know that it's not divisible by 2. So this r here must be 1. So we have it like this. But that was what we wanted to prove. We want to prove that an odd number can be written as 2 times an integer plus 1. So that's the proof. The sum of an odd number and an even number, that is always odd. For example, if I take 7, an odd number, plus an even number 4, then that's 11, and that's an odd number. That this is the case can be proven. So let's now prove that. We know that all even numbers can be written as 2 times m. M is some integer. And all odd numbers can be written as 2n plus 1. So if you have an odd plus an even number, we have a sum of this type. Okay, so we have our even number and odd number. Okay, so we have 2 times, so if you factorize out now the 2, we can write this as this. Here we have a sum of 2 integers, so this is another integer. So we can write this like this, where k is some integer. But then we see that this sum here of an even odd number can be written this way. And if it can be written this way, it means that it's odd, because all odd numbers is written in this way. And thereby we have proven that an odd plus an even number is an odd number, since here we took an arbitrary odd and even number. So this is a typical proof of that.